January 1814. Mayon's fury erased an entire town, leaving just a single stone tower rising from the ash. Now, as the volcano vents nearly 5,000 tons of sulfur dioxide a day, the nightmare that spawned a year without a summer is showing early signs of repeating. What happens if this invisible cloud breaches the stratosphere? The answer could change the world again. Ash rained down on Cagsawa for days, blotting out the sun and turning midday to dusk. In February 1814, Mayon's eruption buried the town beneath a suffocating blanket of mud and rock. Nearly 1,200 lives ended in moments as pyroclastic flows, scorching avalanches of gas and debris, swept through rice fields and homes. The church tower, once the center of the village, became the only structure left standing, a mute witness to the disaster. The landscape transformed overnight. Fields that once fed entire communities vanished under meters of ash. Survivors described a world stripped of color, where crops withered and water turned bitter. For months, the air held the taste of sulfur, and darkness lingered long after the eruption faded. Hunger and disease took hold as food stores ran out and the rivers ran gray with silt. Engravings from the time capture the stark silhouette of the ruined belfry against a sky still choked with haze. These images, passed down through generations, keep the memory of Mayon's wrath alive. The ruins of Cagsawa became a symbol not only of loss, but of the volcano's power to erase entire histories in a single violent episode. Today, as Mayon's crater glows and monitoring teams watch every tremor, the lessons of 1814 remain etched in stone. History is not distant here. It is a shadow cast by the lone tower, a warning that the line between past and present disaster can vanish without notice. Sulfur dioxide is the metric that scientists watch most closely when a volcano threatens the climate. On January 16, 2026, Mayon's daily sulfur dioxide emissions surged to nearly 5,000 tons, the highest in over a decade. This is not just a number on a chart. If Mayon were to sustain emissions at this level for 3 months, the total output would reach 0.45 teragrams, which is 450,000 metric tons. That is enough to raise alarms among atmospheric scientists, but the true risk depends on where the gas ends up. The atmosphere is layered like a fortress. Most volcanic gas rises into the lower layer, the troposphere, where rain and turbulence scrub it out within days or weeks. Only a fraction ever breaches the barrier at 12 to 15 kilometers above sea level, crossing into the stratosphere. It is here, above the weather, that sulfur dioxide lingers for years, forming a thin veil of sulfate aerosols that can block sunlight and cool the planet. Mayon's recent activity has produced gas plumes that rarely climb higher than 2 or 3 kilometers. To reach the stratosphere, an eruption column must punch through the tropopause, a feat that Mayon has only achieved in its most violent episodes. Without this vertical leap, even record-breaking sulfur output will have little effect on global temperatures. The number 5,000 tons per day becomes a yardstick, impressive but only dangerous if the gas escapes the lower atmosphere. Scientists now track not just the volume of emissions, but the altitude of every plume, searching for the moment when local unrest turns into a worldwide threat. Across the Pacific, a chain of volcanoes stirs beneath the surface. In Indonesia, Lewatobi's twin peaks have erupted since late 2024, sending ash plumes up to 9 kilometers above sea level. Merapi, on Sumatra, continues its cycle of explosions, with ash columns rising to 8 kilometers and blanketing nearby towns. These eruptions, while dramatic, have remained confined to the lower atmosphere. Satellite sensors track the plumes as they drift and thin, each one dispersing before it can climb high enough to breach the stratosphere. Despite the spectacle, the numbers tell a different story. Lewatobi and Marapi, like Mayon, produce bursts of sulfur dioxide and ash, but their emissions rarely reach the heights needed to linger above the weather. Reports from Indonesia's volcanology agency confirm that even during the most active days, in January 2026, plume heights stayed well below the critical 12-kilometer threshold. The Darwin Volcanic Ash Advisory Center issues warnings for aviation, not for climate. The idea of a single, unbroken belt of volcanic gas stretching across the Ring of Fire remains unproven. No composite satellite image has captured a merged stratospheric veil from these eruptions. Instead, the atmosphere absorbs each outburst in turn, scattering haze locally, but stopping short of a global shadow. Scientists continue to monitor for any sign that these scattered plumes might join forces, but so far, the evidence points to a coalition of restless giants acting alone. The threat grows not from a single eruption, but from the possibility that these separate events could, together, tip the balance of the climate, if only the right conditions align. Rain on volcanic slopes is never just rain. On January 19th, steady showers swept across Albay, soaking the flanks of Mayon and darkening the gullies that cut through its lower slopes. For families living in the shadow of the volcano, these storms bring a different kind of fear, one that moves without warning and sounds like a freight train coming through the dark. Lahars, or volcanic mudflows, form when water mixes with ash and loose debris, turning entire river valleys into churning walls of mud and boulders. FIVOLX warnings went out as rainfall totals climbed past 50 millimeters in towns like Guinobatan and Legazpi, enough to trigger concern, but not yet enough to set the rivers running brown. The 6-kilometer permanent danger zone was cleared, with over 14,000 residents already in evacuation centers since the alert level was raised. Local officials patrolled bridges and riverbanks, watching for any sign that the rain would tip the balance. Inside the emergency shelters, families listened to the radio for updates, remembering stories of past storms when lahars swallowed roads and fields. The risk is not just theoretical. In previous years, even moderate rain has sent mudflows racing down the Mi-Isi and Bonga channels, carrying rocks the size of cars and leaving behind a landscape scraped raw. The sound, a low, relentless rumble, gives little time to escape. For the people of Albay, each rainfall during volcanic unrest is a test of readiness, and every evacuation is a reminder that the threat is as much about water as it is about fire. The danger is real, even when the rivers stay quiet. If you want to follow these unfolding risks and get daily updates on Mayon's activity, make sure to subscribe and stay alert to the latest advisories. Mayon's silhouette stands out against the horizon, a near-perfect cone rising more than 2,000 meters above the plains. This symmetry is no accident. Each eruption, whether violent or slow, sends rivers of ash and rock cascading down slopes angled at almost exactly 35 degrees. Gravity and heat sculpt these flows, spreading debris in a precise pattern that rebuilds the volcano's shape after every blast. Over centuries, this self-healing mechanism has preserved Mayon's reputation as the world's most beautiful volcano, but it also makes the mountain an efficient vent for gas and heat. Open conduits at the summit allow sulfur-rich plumes to escape with little resistance, channeling emissions straight into the sky. The cone's architecture is not just a marvel of geology, it is the reason Mayon can release massive volumes of gas so effectively, setting the stage for consequences that reach far beyond its slopes. Local legend says Mayon's perfect cone was shaped by the sorrow of Daragang Magayon, her spirit shrouding the peak in clouds whenever danger stirs. Today, her silhouette, captured in viral photographs and centuries-old sketches, reminds people that the volcano's beauty hides a threat. Yet science draws a sharper line between myth and risk. In 1815, Tambora unleashed more than 50 teragrams of sulfur dioxide into the stratosphere, dimming sunlight and chilling the world. Mayon's current output, even at record highs, falls short of that benchmark by orders of magnitude. But another wild card lingers above. The water vapor injected by Hunga Tonga in 2022 still saturates the stratosphere. If Mayon or any volcano manages to breach the upper atmosphere now, the resulting aerosols could spread faster, linger longer, and amplify cooling beyond what models predict. The odds are low, but history has shown that rare alignments can tip the balance from legend to reality. Today, Mayon pushes close to record sulfur emissions, and the world watches for the next shift. Planetary climate can pivot in a single season. Science offers warning, not certainty. As we track each plume and rainfall, one truth remains. Nature always writes the next chapter. Stay alert.